Hello and welcome to our final video for this semester about Introduction to Game Programming. The goal today is to talk about how to transition to Unity. The goal being that we can take everything we've learned throughout the semester and use it in an actual commercial game engine. The advantage of using a real commercial game engine is that it will support all sorts of asset types, not just circles and rectangles and lines like we had in class, but it will also be able to publish your game across a variety of formats, not just to the web. As we'll see today, working with Unity, that does come with some drawbacks. We'll talk about that as we go. My goal today is to recreate the first game we made this semester, which was our guards game. It had a few simple scenes, a character that moved around with keyboard, and some guards that moved back and forth with a sign function. If you touch the guards, you lose the game. If you get past the guards, you win the game. And after you get to one of those end scenes, they transition back to the main scene after a few seconds. So let's get started. In modern Unity, when you actually download Unity through something called Unity Hub. So you install Unity Hub and a version of the Unity IDE. And once you have that installed, you can create a new project. So I'm going to come in here and create a new project. And there's lots of options here. The big thing that we need to stick with is we're going to be doing a 2D project. We're going to keep it in 2D so it looks like the game we made. And then over here, we're going to give our project a name. So I'm just going to call it Guards Game CS 2510. Okay, pick a location for where it goes. The organization we use only matters if we're using Unity's online services. They're really promoting these right now. It's also a way that they can monetize what they're doing. Since we're just creating a very simple game, we're not going to use any of Unity's cloud capacities. We'll come here and we will create the project. We'll have to wait for a minute while the Unity engine loads and prepares itself to get going. One of the big changes with Unity over our game engine is that Unity uses C#. C# is similar to Java in the sense that it's statically typed and strictly typed. So when we start working with code, we will have to make sure that all of our variables have a type. So it's an integer or it's a float or it's a string. And all of our lines will have to end with semicolons. So for those with just a JavaScript or Python background, these will be some changes. Other than that, the syntax of C# looks a lot like what we did in class this semester with JavaScript. We're going to use curly braces to offset blocks. The comment format is the same. And since we're not going to be using any of the really advanced features of C#, at a quick glance, it may look like we're actually just using a language very similar to JavaScript, which we are. So Unity has a lot of power, and so it has to load a lot of scripts in order to load the IDE in the first place. Unity supports a variety of different languages, although C# is the only officially supported one. They do actually support JavaScript. You can write all your components in JavaScript, but that's no longer considered a best practice. The way that Unity does this is it takes all of the languages that it supports and allows those in the back, it transpiles those languages into something known as an intermediate language that it can understand with its C and C++ engine. By doing that, it can take whatever you write and transition it from intermediate language into whatever platform you're moving to, whether that is the Switch or a Mac device, etc., etc. When we do have the IDE open, there's lots of options, things you can do. But the most important thing to remember is that the architecture in Unity is the same. Everything we do will be composed of scenes, game objects, and components. So as long as we keep that in our mind, then the exact way that we make the game just comes down to a few technicalities about how Unity thinks and how it acts. So first thing we're going to do is take a look at the IDE to see where scenes are, where game objects are, and where components are. Okay. And here we go. We have the Unity IDE up and running. Okay. There's lots of things going on here, but if we take a look at them one at a time and think about them in terms of scene, game objects, and components, we are good to go. By default, the Game tab shares the same space as the Scene tab up here. I like to separate them so that I can see the game playing without having to flip between the two tabs. If when you open up your Unity, it looks a little bit different, that may be one of the reasons. Other than that, we have a fairly standard layout here. By default, it shows you the project tab down here. Right now I have it open at the console, but we can move back real quick. Okay, scenes, game objects, and components. If you look down here, this is like a file viewer in VS Code. We see the files that are inside of our project. And over here, one of the first things we have is a folder called scenes. And inside that folder, we have our first scene. When we select a scene, the scene is shown up here. Okay. Right now I see that my scene has a camera and not much else. All the game objects in my current scene are listed in here. So if you look at the files we have from our engine, you would see inside your scene file a bunch of statements to add game objects. That corresponds with what you see here. When you select a game object, all the components attached to that game object are over here in the inspector. Okay, so scenes, game objects, components. So let's get started by creating a project layout that mimics what we've been doing in class so far. So I'm going to come down here, I'm going to click on assets, which is the root folder for any project. I have a scenes folder. I'm going to right mouse and I'm going to create a new folder, and the folder I'm going to create is going to be called game objects. Okay. Some projects call their game objects folder prefabs, but the idea is the same. I'm going to right mouse here, go to create a new folder, and this folder I'm going to call components. Okay. It's going to correspond exactly with what we've been doing in class. So I have scenes, game objects, and components. Don't have any game objects or components yet. That's why the folders are empty. But we'll go through and we'll fill all these up. So let's come in here, and I have my first scene, which is called a sample scene. I'm going to rename this sample scene to main scene. So if I hit F2, I can rename this to be main scene. And I'm going to come over here and create two new scenes. One's going to be called win scene. One's going to be called lose scene. So we have all the scenes we're going to make in this game. So I'm going to right mouse. I'm going to go create a scene. And then in here, I'll call this win scene. And I'll do that again. Come in, create a scene. I'm going to call this lose scene. Now, in order for Unity to understand that your scenes exist, you have to manually go in and tell Unity that these scenes are going to be part of your final project. So we have to do one more step in addition to creating the scenes that I want to have. So I'm going to come up here and I have to click on File, Build Profiles, and I'm going to click on Add Scene List. And in here, I can add scenes to my entire project. And I'm going to add scenes that are open. So my main scene I already have open. So I'm going to come in here and double click on Load Scene. Lose Scene. Now that's open. Come back here, Build Profile, Add Open Scene. Close this, double click on Win Scene. When that's open, Build Profiles, Add Open Scene, and there we go. Okay. So Unity knows about my different scenes. Let's go through and populate these scenes so they have something to show. In the class, the only thing we had in our win and lose scenes were just a piece of text that says you won or you lost, and then a game object with a component that transitioned back to the start scene after 3 seconds. So we're going to start by adding some text, and then we're going to go through and add a component to a game object to move us to the main scene. So in our win scene, we are going to first set the background color. The way you set the background color is in Unity is by clicking on the camera and then coming down here into environment. By default, it's a skybox. That's something we talk about sometimes in 3D graphics, but not in this class. Let's change it to be a solid color. And in our win scene, we're going to change this to be black. We'll make both of our scenes in scenes black. Okay. And then we're going to add a new game object, and that game object is going to have a text component on it. And we'll write, you won the game inside that text component. So we're going to right mouse here, which is like adding a game object to a scene. Then we'll come down here and decide what we're going to add. Since text is part of the UI, we're going to come down to UI, And we're going to come down to legacy and click on text. The reason that Unity labels text as legacy is because it's trying to introduce a new format for text called Text Mesh Pro. But it can be problematic, and the legacy text is very dependable. So I'm sticking with that even though it's labeled as legacy. So I'm going to come in here and give my game object a name, and I'll say when text game object. Okay. The way that Unity puts game objects into screen space is by creating a special game object called canvas, and anything inside this canvas is drawn to screen space. You might also notice that it added an event system to my game as soon as I added a UI. That event system corresponds very closely to our events class that we made in class, where you could add listeners and handle events. We're not going to focus on that today. We're going to focus on the text we just added. It's really hard to see the text because it's small, and by default the color is gray. You can see it down here on the screen for my game, and it's just very gray. So I'm going to come down here and make this a celebratory color because we just won the game. So we're going to make it green, and let's change the text to "You won the game." Okay. What I'm doing here is I'm going through and changing the values inside components on this game object. So each one of these collapsible panels represents a component in the game object. So there's a transform, because everything has a transform. There's a canvas render, and then the text component itself. Okay, so I changed the text on my text component. It's called text, which is what we called it in class as well. And then let's reposition it so that it's easier to see. So we won the game. We're going to click on this. If we scroll out, here's a picture of the screen space. I'm going to center this here like that, and it says you won the game. Okay. The font's still a little small, so just like we could with our components in class, you can change the value of the font and it will get bigger. Unity requires that you make your object a little bigger to see all the text, and it says you won the game. Feeling good. Now let's open up our Lucene and make it so it says that we lost the game. So double clicking on Lucene, I'll ask if I want to save changes. I do. I'll come in here and do what I did before. I'll select my camera, change from skybox to solid color, change to black. And then I'll come in and I'm going to add something to the UI. So I'm going to get a new game object with some text in it. I'll rename it to lose text game object. Come in here and change what it says to say you lost the game. Okay. Make it a little bit bigger like we did on our other scene. Change this to be a terrible red color because you lost. I'll come in and reposition it so it's roughly in the same. So if I move to my win scene, it says you won the game. Go to my lose scene, you lose the game. But what we want to change is we also want to add a game object that has a component that tracks how long it's been and when 3 seconds have elapsed. Then we change to the main scene. So this is where we're going to take advantage of our game objects folder, and we're going to create a game object that we can use more than once. So I'm going to come over here into game objects to make sure this is open. I'm going to come over here and I'm going to right mouse and I'm going to click on create empty. This is the equivalent of in our scene file saying add new game object, and inside of it saying a new game object. It's just a generic game object that we're going to add a component to that has some job. We won't be able to see it. It will still have a transform because everything has a transform, but that's all we'll have. So we're going to name this end scene game. I'll just call it end scene controller. Okay. So still has a transform. It's invisible. We want to add a custom component where we write the code ourselves. That says after 3 seconds, let's move back to the main scene. So I'm going to click main component. If I don't have anything typed in here, there's a whole bunch of components that come with the engine. If you remember, our engine had a folder called components where we included everything that came with the engine. This has the same idea here. If we want to create something that's not part of the engine, we can either come down to new script and type in the name of the script, or if we search for something that doesn't exist, it just assumes that's the name we want for our new script, and off we go. So call this new scene controller. Wait for a second, and our in-scene controller component now exists here, since it's a script. It'll think for a minute because it realizes it has no new code, then it needs to convert into intermediate language. Okay, and if we come down to our assets, we'll see that the in-scene component file was not put in our components folder. So let's move it into our components folder. Okay. And then if we double click on that file or we double click on the component itself, we'll be able to open the code inside of an IDE. So as soon as that's done, we'll double click here and it's going to open up our project in Visual Studio Code. So one thing that's worth noting is that by default, Unity uses Visual Studio, not Visual Studio Code. So if you have a vanilla install and you just double click on a script, it'll open up Visual Studio, but it works just as well. There's an option inside of settings inside Unity that says use VS Code instead. So here is the default information, default text inside of a code file from Unity. First is a statement that says we're using the Unity engine. In C#, this includes a bunch of files and classes that help us out with everything else we're doing. If you're used to import statements, it's the same concept. On line 3, we declare a class in scene controller component. In C++ and C#, instead of using the word extends, like in Java, they just use the colon symbol. So in Java, you'd read this as class in scene controller component extends mono behavior. Mono is the name for the open source project that allows you to run C# on any system, not just Windows. Mono is now deprecated because C# has been released on all systems and platforms by Microsoft, but the name mono behavior derives its origins from that. So it's a reference to the old version of C# that Unity used to use, and then behavior being a specific kind of component that's defined by the user. So we use the component class in our course, but in Unity it's called mono behavior. If you're not familiar with these accessibility modifiers, because you don't have a Java background, they can be a little bit different. We're just going to leave it alone. Essentially, this says that any other class inside of our C# project can know that NScene controller exists, as opposed to a private class. But we're never going to touch that in Unity. By default, Unity gives us two functions, start and update, which is what we're used to. You may know that C# uses a different convention than JavaScript, and it starts all of its function names with an uppercase letter as opposed to a lowercase letter. That's just one slight difference, but the concept is the same. Start and update. Start gets called once when the game object loads inside the scene. Update gets called every time there's a tick inside the game engine. Okay? So we want to tell Unity that after 3 seconds, we want to change scenes. And the way we're going to do that is we're going to keep track of the amount of elapsed time by querying time.delta time. So in C#, we can't declare variables on the fly. We have to declare all the variables inside of a class outside of the constructor or the start function. So I'm going to add a new line here and say I'm going to create a new variable called elapsed time. Set it to be 0. Now this is invalid C# syntax for 2 reasons. One is I need to declare the type of elapsed time. Since this is a number, we need to declare it as a float. All right, so this will tell C# elapsed time is a number that can have a decimal. And it's also frustrating because I don't have a semicolon. All the end of lines in C#, all the C++ and Java convention of always needing a semicolon. So we have elapsed time. And what we'll do is we'll come down to update. And we'll say that every time there's an update, we'll just increase elapsed time by the amount of time.delta time. So like we had in class. Like in our course, there's a class called time with a variable called delta time that keeps track of how long it's been since the last time update was called. By doing this, we keep track of how many seconds it's been since this object started. And then we'll have an if statement here to check to see if it's been 3 seconds. We'll say if elapsed time is greater than 3, it's been 3 seconds, then we want to change the scene. Another quick note is that in C#, we don't have to type the word this for variables that belong to a class instance. We can, and it's not syntactically incorrect, but the best practice is to leave it out. So if you were to copy and paste your code from JavaScript into C#, one thing that you could do is take out the this command. Okay. The way that you change scenes in Unity is with the scene manager class, and the command is called load scene. And we're going to pass in a string that is the name of the scene that we want to load. Okay, so keep track of last time, increment it based on what time.delta time is if it's been 3 seconds, and then we change to our main scene. Let's come back here and see if we can get this to work. I'm going to take a second to compile what we've just created, refresh the entire project over here in Unity, but once it's ready, we can play the game, starting with whatever scene we have loaded. We have the lose scene loaded, so I come in here and push play, it will play the game as if we just lost the game. You can see that in here once it starts. It'll say you lost the game. And then hopefully after 3 seconds, it will move us into our main scene controller. So here we are playing the game, and after 3 seconds, we went into our main scene. So let's stop the game. It takes us back to our lose scene game. I noticed that I misspelled this, so let me fix that real quick. Instead of you lost the game, let's change this to you lost the game. Feeling good there. And I have an in-scene controller that contains the component that changed scenes for us. I'm going to click on my game object folder and drag this game object into this folder. By doing this, I've changed it from being something that's declared anonymously inside the scene file as something that exists outside of the scene itself and can be used in any scene that I want. You'll notice that it changed the icon here to blue to tell me that I'm using something that's a game object that exists outside of just the scene. What this lets me do is if I go into my scenes and change to my win scene, save my changes, I can then drag this in scene controller into this game, and the win scene will have the same behavior. If I push play to watch what happens after 3 seconds, we should transition from the win scene to the main scene. So wait, transition, we're doing great. So that gives us our initial introduction to game objects, different scenes, and the components and how you write them in Unity. Let's finish by taking a look at the main scene and making it so that we have a player game object and some guard game objects that we can avoid to win the game. So I'm going to open up my main scene, and I'm going to create a new game object that will represent my player. So I'm going to right mouse, and this time I'm going to go to 2D object sprites, which is another name for an image. I'm going to come down to my circle. Okay. I'm going to rename my circle to be player game object to match what I had before. Okay. And if I double click, I can see where that is. We can see where that is relative to my camera. There we go. Yeah, I don't know, it's not letting me move that. Let's make sure the player game object was created way off somewhere. So I'm going to go into the transform and recenter it at 0, 0. Okay, there it is. Right now, centered on my camera. Like before our position, we didn't touch rotation in class and scale, all right here inside of my transform. So let's change the color of my player. Instead of having white, let's change my player game object to be green, or whatever color I want. It's great. And then I need to add a component to this game object so I can move it around. So I'm going to come down here and add a component. I'm going to come down and say new script, and I'm going to name this keyboard movement. I'll wait a second, and as soon as it's ready, it will add that component. If I double click on keyboard movement like this, then I'll see this file here inside my editor. Once again, it put my component inside the root of my folder. I want to move it inside components so everything's tidy. Okay, so now I have it inside components. So when I push a key on the keyboard, I want my main player to move. So I'm going to create two variables, one for movement in X, one for movement in Y. I'm going to query the state of the keyboard and then update those. And then based on that, I will move my character around. So I'm going to come in here and create two variables. First is going to be my change in X. Second one will be my change in Y. So delta X, delta Y. And then I'll set up a speed variable. I'll set it to some number. We'll set it to 3. Then I'm going to write 4 if statements to check to see if up, down, left, right are being pushed, and adjust delta X and delta Y accordingly. So let's say if, like before, we have an input class, and then the function we're going to call is called getKey. The key we're going to check for is going to be key code dot left arrow. So Unity has a whole bunch of built-in keyboard key symbols. They're slightly different than the ones in JavaScript. JavaScript is arrow left, not arrow right. Excuse me, not left arrow. We're going to use that one and say if that is true, then we'll say that delta X equals -1 times speed times time dot delta time. We always want to use time dot delta time because it can change depending on the number of frames we can throw out per second. Okay. Copy that down and change this to be from left arrow to right arrow. I'll change this to be positive. And then I'll come in here and do it again. And I'll do something for the up arrow and for the down arrow. Now, one important thing to note is that in Unity, positive Y is up. We're used to having positive Y being down. So that's why up is a positive number and down is a negative number. And then we need to change this to be not delta X, but delta Y. Okay. And then we're going to tell our character to move. The way we did that before is we said this dot transform dot X. In Unity, your position is stored in a separate variable called transform dot position. But the way that Unity works is it doesn't let you manually change the value of the X and Y values on vectors because they're immutable. Okay, there's technical reasons that they want to do that. So if you want to move something in Unity, you have to assign a new value to position. Because Unity is fundamentally a 3D game engine, we have to use vector 3s because we have 3 dimensions. And then we can go through and specify the new position. But it's easier if we aren't just moving to a random location to use a helper function called translate that tells Unity how much something should change in its position. So we'll say just change in however much we want to change in X, however much we want to change in Y. Then we always have to pass in the Z, and we'll set it to 0 because it's a 2-dimensional game. Okay, so if we've done this right, when I push keyboard keys, my character will move around on the screen. So we'll pop back over here, wait for a second, play the game, and hopefully when we play, when I move my arrow keys, off we go. So you can see that within the game window, which is the main one here, I can see my circle moving. Over here, which is the editor for my scene, I can also see it moving temporarily, but as soon as I end my scene, it's going to go back to its starting position. So we have movement working correctly. Let's come into my keyboard controller component here and say that if we go further enough down, then we'll end the game and move to the win scene. So we'll say if this dot transform dot position dot Y is less than -2, Then we're going to go through and say scene manager.load scene, and we want to load the win scene. Okay. We need to make sure we have our strings written correctly, and as I mentioned before, we don't have to use this keyword when we're working in Unity. So let's hit play. Watch what happens when we move our character down farther. All right, moving around, we go further enough down, it says you won the game, and hopefully after 3 seconds, it'll pop us back to where we started. Excellent. I noticed that I misspelled player game object here. We can hit F2 to change it, or go into inspector and change the name of the game object. Okay, so that's been improved. So all I need now to finish off the game for this video is to add some guards to the game. So let's do that. As we come down here, we're going to have more than one guard. So we don't want to create this as an anonymous game object. We want to create it, make it a game object that exists outside of just its anonymous definition. So we can have more. So I'm going to come over here. I'm going to create a new 2D sprite. That's a circle. I'm going to name this guard game object. Okay. And let's change our guard to be a red color. And then because I'm going to use this more than once, I'm going to open up my game objects folder and drag that down here. You notice how it turns blue. Now changes that I make to this will be reflected when I have. Before I do that though, we can't start overlapping. So I'm going to select my player game object, come down here and move it up a little bit so we don't start the game by losing. I'm going to come over here and we're going to add a new component, and it will be our guard movement. So if I type guard movement, we'll recognize that I need a new script. I'm going to create that. We're going to come in here and edit the guard movement. Like before, we need to move it inside of our components folder just to be tidy. Okay. And when I start my guard movement, I want to keep track of its original X and Y location. So I'm going to come in here and say float start X and then float start Y. And for the first time, we're going to use the start function. So we'll come in here and we'll say that start X equals transform.position.x and start Y equals transform.position.y. Once we have that information, we can go through and update the position of our third game object with time really easily. We also want to keep track of elapsed time. So let's add some semicolons, come down here and update. The first thing we're going to do is we're going to update our elapsed time based on delta time. Okay, feel good about that. And then as time passes, let's just set the transform position. So we're going to say transform dot position equals a new vector 3. We're not going to translate it. We're just going to say this is the new value. And in X, we're going to say start X, and then we're going to use our sine function like we did before. And we're going to multiply it by 3, so it moves back and forth more than just one unit. We want to maintain our start Y, and then our Z is always going to be 0. A real quick comment. C# by default comes with a math class that provides things like sine and cosine. But by default, C# does everything with doubles, not floats. Double takes up twice as much memory as a float does. It ends up in graphics applications. We don't need that kind of precision, and saving memory is really important. So everything in graphics is done with floats. If you've taken computer graphics, you'll recognize this because the only thing you can do on a GPU is called a float. So in order to not have the problem where you're constantly casting from doubles to floats in Unity, they added a new class called mathf that has all the same math functions, but they all just use floats. So we're going to use the mathf class when we're calling our trigonometric functions. We're going to grab the sine, moving back and forth in X, maintain a constant Y, and off we go. So with all this put together, let's try playing our game, and hopefully we'll see a enemy moving back and forth. Nothing will happen if we run into the guard yet because we haven't handled that use case. It says we have a compiler error, so let's open up our console here. And it says that we are expecting a semicolon, which is something that we get a lot coming from JavaScript and Python. So let's add that semicolon over here. Run back over here. Wait just a second, and then we should be off and running. So we're going to hit play. It's going to import everything and get ready for us to run around with an enemy. So our enemy is moving back and forth, move around, nothing happens when we're in contact. I go further enough down. Okay, exactly what I want. So let's pop back up here. I want another guard game object, and I want it to be the same game guard game object. So I'm going to come into my game objects and drag in this guard game object, and now I have two. If I drag the second one down and push play, I should have two guard game objects that are moving to the left and right. So waiting for this to run, it's going back and forth. I'm feeling really good about that, but the second one is not doing it. So this is what's happening. I made changes here inside the scene view without actually going inside the shared game object. So if you click on this little arrow here, it takes you inside the actual guard game object that's shared across the scene. So in here, I'm going to come in and say, I would like to add a component. Guard movement already exists, so I'll add that. I'm going to pop back out. Okay. And it's been added twice because it exists in both contexts. So I'm going to remove the one that I added. So we're just relying on what we added inside of when we isolate it. So guard game object here uses guard movement on the other one. Hit play, and both of them should be moving around quite nicely. So hold on, wait for this to compile, and we have two guard game objects moving back. So we're almost ready to be done. One problem that we have with Unity is that Unity's collision system is far more complicated than what we did in class, and takes a little bit more work to get working the way that we want, where we just want to check to see if we're in collision with the circles. Specifically, Unity does not support us directly querying whether or not two objects are in collision. What happens instead is that Unity notices when two objects are in collision and sends an event that says, hey, you collided with something, you should do something about it. However, that system is not enabled by default. We need to go through and we need to add the appropriate components to both the player game object and the guard game objects, so that Unity knows they need to be part of the system. And then we can listen for events that tell us when objects are in collision. So in my player game object, I'm going to add a rigid body. Now in class, when we added rigid bodies, we did it because we wanted physics, and that's not what we want here. However, we need it in order for Unity to look for collisions. What we're going to do though, you're going to come in here and it says under body type, we're going to change this from dynamic to kinematic. In Unity, kinematic means we're not going to use any of the velocity or gravity systems that come with rigid bodies. We're just going to use it essentially for collision detection. We're going to come down here and turn on full kinematic contexts so it knows that this is kinematic and we're listening for collisions. In addition to that, we're going to add a new component, and it's going to be a circle collider 2D. This tells Unity to surround our sprite with a circle, and if anything comes in contact with that collider, then we need to know about it. Come in here, make this a trigger. So it'll call the event when something happens. And now I have collision detection enabled for my player game object. I need to do something similar for my guard game object. So if I go to my guard game object and click on the arrow, so I'm adjusting all of them, I come in here and I add a new component. I don't need a rigid body on the guard game object. I just need the circle collider 2D. I'm going to say you are a trigger. now, if we've done it right, Unity will tell us when our player game object collides with our guard game object. So I'm going to go into our player game object and go into our keyboard movement and tell my player game object to do something if there's a collision. The way that you, listen for collision in Unity is you add a function here, and we want on trigger enter 2D. We're using the 2D system, rigid body 2D, circle collider 2D, and we want to know when our trigger has been entered by something else. Okay, so I'm going to just log something here when that happens, because when you're working in Unity, this is a great way to help debug, is you do debug.log. Okay, like all languages, there is a way to write to the console. So coming over here, we're going to pop over to the console, and hopefully when we have a collision with the guard game object, it will say, hey, there was a collision. So let's push play over here. Let this boot up. It's running back and forth. Come over here and it says, hey, we had a collision. Because we were just listening for collision enter, it only tells us when a collision starts. So Unity keeps track of if two objects are in collision. It only calls that function again if we have stopped being in collision and then gotten back into collision. So the last thing we need to do to make this game complete is to just change scenes if we have had a collision. So I'll say scene manager, load scene, and we're going to load the lose scene if there's a collision, and Alt-Shift-F will fix that for me. Save that file, come back over to Unity, and let's see if we can lose this game in addition to beating the game. So it's going to think for a second. We're going to play, and off it goes, compiling everything one last time. I'm going to move down and intentionally run into my guard game object. I lose the game. After 3 seconds, I'll get a second chance. Come back in here and win the game. I feel all right. So real quick, where can you go from here? If you want to expand the game by having more scenes, for example, after you beat the first scene, there's another scene. You would come in here into your scenes folder, create a new scene, and change the code over here so that you win the first time. Beat the first scene, you go to the second scene instead of the win scene, etc. If you wanted to publish this game, you'd go up to File and then Build Profiles. And then here, there's a whole bunch of different ways that you can publish what you've created. Okay. By default, Unity just comes with Windows and the web, but you can go through and change it to be desktop or for console. Once you have all of that set up, you can click on one of these and then say build for that particular scene. So I clicked on Windows. If I go to build or build and run, it would go through and create a Windows build that is downloadable that I could put on itch.io or publish through Steam. Same thing with the other profiles over there. So thank you very much. That is how you move from our game engine to using Unity.